Hi, my name's Bev Watford. I'm the Associate Dean for Equity Engagement in the College of Engineering here at Virginia Tech. If you've ever visited Virginia Tech at any time in the past or listened to any of our videos that we've done over the last year, you may have heard some of this information already, but it's always good to hear it again. Okay, so the first thing we usually talk about with students is what does it take to be an engineer? And we always emphasize the fact that we are very creative. We work in teams a lot, that we're always working with somebody else. We have really good study habits. We have to. Engineering is a very challenging field. We also have an interest in math and science. You don't have to like it. Nobody says you have to like it, but you do have to do it because you will be doing it for quite some time. And most of our students come from a fairly challenging high school background. They take a lot of AP credit, dual enrollment, but a lot of our students also don't. They just take their regular courses through high school, so don't feel that that will set you apart in any way. Our freshman class for last year, the class of 2020, the average GPA was about a 4 out of a 5, and again, that's an average. That means there are people above that and people below. We've got average SAT scores, math of 689, reading of 649. I always laugh and tell people, engineers can read, we can write. We do those things very well. And we're about 23% women. We're still working on that. Broadening participation is something that we feel very, very strongly about, allowing everybody who wants to be an engineer to become an engineer. So other underrepresented minorities represent another 26% or so of our freshman class. So as you come into general engineering, you might have applied and you might have selected mechanical on your application or industrial on your application, but everybody comes into freshman general engineering. And the reason for that is to allow you to explore the different engineering fields that we have to offer. I can tell you, you could not name all the fields that we have. We have engineering fields that you've never heard of. And they're really, really fascinating. I can tell you, I ended up getting a degree from Virginia Tech in mining engineering. And I'm from New York. We don't have mines on Long Island. So it was something that was completely new to me, but I was really fascinated by it. If you want, you can always go online and look up your AP classes, your IB classes, your CLEP classes. There's a transfer guide where you can actually look and see, and it'll say, if you took this test and got this score, you get credit for these classes at Virginia Tech. All you have to do is go on the website, the homepage, and type in transfer guide, and they'll hook you up right with that. We also have a general education curriculum that all university students have to follow. And that's kind of ensure that we graduate really well-rounded people in the arts and the humanities and the social sciences, as well as the specific discipline that they want to study, or in our case, engineering. What happens is you take a Foundations of Engineering class in your fall semester, your freshman year, and they will actually have you go and listen to presentations from the different departments to explore. Then in the spring of your freshman year, sometime around March, you will be selecting classes. So that's when you're going to have to make a decision about what engineering field do you really want to follow and explore. So the Foundations class also teaches you about data collection and analysis. They teach you about engineering problem solving. They teach you about modeling and design, teamwork, different engineering professional practices, and then, as I said, the engineering fields and majors as well. So it's a great opportunity to explore, and it gives you the chance so that you don't feel like you're so rushed in picking a particular field. Okay, so let me see if I can name the different engineering fields that we have for you here in the College of Engineering. We've got aerospace and ocean. We've got civil and environmental. We have electrical and computer. We have mining. We have biomedical. We have chemical. We have mechanical.
Biological systems.
We have biological systems engineering. We actually have 2 engineering fields that are part of 2 different colleges. Biological systems engineering is also part of the College of Agriculture, and construction engineering and management is part of the Myers-Lawson School of Construction, which is joint between the College of Engineering and Architecture. So you can see we're very interdisciplinary. We work a lot with the medical school and the people over in the health sciences area. The other thing that I really like about being here at Virginia Tech are the minors that we have. We have some engineering minors. You can get a minor in computer science if you like. Some other fields include material science and engineering and industrial engineering, which happens to be the field that I got my graduate degree in. One of the things I really like about the engineering fields is, as I said, how broad they are. So if you were studying, for example, civil engineering, let's suppose that's what you wanted to do, you could actually end up working in the transportation industry, or you could end up working in the environmental industry, or you could work with geotechnical. And it's amazing the different things that you can do with one degree, a civil engineering degree. So one of the things that we really prize here is the experiential learning opportunities that our students have. They have co-op opportunities. We have an Office of Career Services that is dedicated to helping you find a position, whether it's a part-time, full-time, internship, externship. That's their job. So we work really hard for our engineering students to get out there and apply what they learn. It's really, really exciting. And when you start looking for a job, one of the things that you'll find out is there are a lot of Hokies out there, and they like hiring Hokies. So we have our own little network going on in different companies. It's really, really good. We also have some fabulous living learning communities. You might have heard about these in some of the other sessions that you've been in, but basically a living learning community is a group of people that have something in common that are living together in the same space. In our case, we have HYPATIA, which is an engineering community for women, and GALILEO, which is an engineering community for men. Together, they call them GALIPATIA. They live in Hogue Hall. It's about 600 freshmen and about 200 upper-class students. And it's really one of the most fabulous programs that we have. The students have wonderful opportunities. Every Friday, for example, there are visitors from industry and from faculty that actually come into the residence hall and just talk to the students. We tell them you can't bring a PowerPoint, you can't bring a display, you just want to talk about yourself and tell the students who you are and what you do. GALILEO and HYPATIA consistently rank among the best living learning communities on campus, so that's something I want you to check out. And I know you're sitting there thinking, yeah, I don't really want to live with a bunch of engineers. Yeah, you do. Let me tell you, you really do. It's a lot of fun, it's a lot of support, and the students who live there don't regret it. So just talk to some of them. We also have a peer mentoring program that's based on a corporate model, where what we do is we hire upper-class engineering students to serve as peer mentors for freshmen. So they're there to answer any question that you have about anything, about the residence halls, about the food, about the classrooms, about town and the different weight clubs that they have, about Blacksburg Boxing and Fitness, which is something that's really hot these days. You can ask them about teachers, you can ask about internships. You can talk about the homework that you've got in a class and how you're struggling with it or you need some help, and they'll help you. That's their job. They want to see you be successful, just like they have been. So that's something to think about. Another opportunity that we have is a summer bridge program. So think about transitions. You are about to transition, right, from home and high school to living away from home and college. The STEP Summer Bridge program helps you do that. So we bring students here for about 5 weeks over the summer. It's not for credit, but they take classes in engineering and math and chemistry. They meet faculty, they meet their advisors, they become familiar with the campus. It's a lot of fun, and the students really feel that it gives them kind of an edge on the other students when classes start in the fall, because they've already been here, they've already lived here, and they pretty much know what they're trying to do. So think about the STEP Summer Bridge program as well. One of the other things I really like about the College of Engineering is we have some great toys. So, you know, we are a Research One institution, and being a Research One institution carries with it some perks. And those perks are that we have the funding to be able to provide a lot of really wonderful opportunities for our students. So we've got the Ware Lab, and the Ware Lab is a student projects lab where the Formula Car team puts together the Formula Car, and the Mini Baja team puts together that, and we have a hybrid electric vehicle, and we have a concrete canoe, and we have drive, build, fly. We have all kinds of autonomous vehicles, autonomous underwater, autonomous in the air, autonomous on the ground. And these are projects that any student, regardless of major, can participate in. It's just something that if you want to do it, you can. Sometimes students participate in these projects as part of their undergraduate research. They actually have a task that they have to accomplish for a grade. Sometimes they just do it for fun. And then there are student competitions across the country. So we are competing. Our hybrid electric vehicle is going up against vehicles from Penn State and Georgia Tech and MIT. And we often do extremely well against these schools. So you can look up those competitions and see just how wonderful we are. I'll give you one that was really exciting. Our solar decathlon team, they built a solar house. They ended up in Dubai at the international competition, and they won. They got first place internationally. So that's how good our students are. So one of the things I should say is it's our job to make sure you get a degree. So we have all kinds of support available for students. We have academic support, we have networking support. I mentioned the peer mentoring program, the living learning community. So we've got great statistics. Our students, about 74% of them are employed after graduation. The rest of them are often in graduate school, earning advanced degrees. Median starting salary is now around $70,000. So yeah, engineers make good money when they get out of school. We do have a computer requirement, just like the rest of the university. That's something you want to wait until late spring or just before you come, before you go ahead and buy a computer. But the requirements are online, and mostly it's, digital inking and being able to communicate. A lot of times you're going to be submitting your homework online, getting it graded and sent right back to you online. So you want to check out the computer requirements and make sure you buy what is necessary. And PC or Mac, either one works, whatever you prefer. You can actually learn more by scanning our QR code, and that'll take you to the computer requirements page. There's also an Explore Engineering page where they talk about the different engineering fields, the different organizations associated with that discipline, and examples of different jobs that you could get if you were to get that particular degree program. So again, we're really trying to offer you as much information as we can to help you be successful here. So I know your senior year was not the way you wanted it to be. With the pandemic, frankly, none of us are really happy with the way things are right now. We miss people, we miss getting together. We miss being in the classroom with our fellow students and teaching. But we're ready. We are ready for this to be over. We are hopeful that by fall semester, everything will be back to normal. You'll be in the classroom with teachers and friends. You'll be in the residence halls and going to football games and basketball games, and life will be just as exciting as it was before the pandemic. So we've got our fingers crossed for that, and we'll see what happens. But even if it's not, we're still here. We are still providing a quality education for our students. We're still offering them different opportunities, like undergraduate research and students doing externships and internships. We're trying to make things just like they were, despite the fact that we are maintaining our social distances and wearing these lovely masks. So the last thing that I'll say is, there's always that question of what's a Hokie? And I hope that sometime this year, you'll accept the offer and you'll say, I am.
Hello, my name is Dewey Spangler. I am the manager of the Ware Lab for the College of Engineering for Virginia Tech. The Ware Lab has been in existence since about 1998 when Joe Ware gave money to set up a lab that's for undergraduate students primarily. Students here work on senior design projects, and they also work on projects that are independent study. A lot of students here in the lab are volunteers, and some receive credit. But the vast majority of the students here are here because they enjoy what they're doing and they want to get hands-on experience during their engineering studies here at Virginia Tech. We have 10 projects at Virginia Tech, at the Ware Lab, that about half of those are mechanical engineering projects, and we're going to learn more about those in a minute. But I'll give you a quick rundown. For mechanical engineering, we have the Formula team, we have the Baja team, which you can see 2 of their vehicles in the background here. We have the hybrid electric vehicle team, which takes a GM vehicle and converts it to hybrid technology. We have the Bolt team, which is an electric motorcycle team. On the aerospace side, we have Design Build Fly, which builds a remote control airplane. We'll learn more about that in just a moment. And on the ocean engineering side, we have Human Powered Sub, which, as the name implies, is a submarine which is submerged. It's a wet sub and is powered by human beings. It's a wet sub because it doesn't need to be pressurized. It makes it easier to go underwater. Also on the ocean engineering side, we have Sailbot, which is an autonomous sailboat. And on the civil engineering side, we have Steel Bridge and Concrete Canoe. So those teams are mostly club teams. The mechanical engineering teams, they have senior design components. But for all the other teams that I mentioned, it's mostly volunteers and it's people here just because they love what they do. You saw earlier the Baja cars out in the showroom. This is an actual project bay where the Baja cars are constructed. So every year students have access to this space. This is about 200 square feet. So that's a lot considering this is a research university and space is very limited. So students, if you look around, they have tools, they have plenty of equipment, they do their own machining. These are parts that are fabricated for this year's vehicle. So it's a real deep immersion into the project.
When you're ready.
Hello, my name is Adam Yee. I am a senior currently at Virginia Tech and I study electrical engineering. I'm part of the Formula SAE team. Currently I'm working on some emails, but as well as some Altium schematics. We design, test, and then manufacture our printed circuit boards and make custom printed circuit boards for safety that are required by competition. And so we're glad to have an Altium sponsorship that they give us the program and we're actually able to, from start to finish, actually create our own printed circuit boards.
Awesome. So my name is Shreya Chandramoli. I'm a fifth-year aerospace student here at Tech, and this is DBF. So basically, we design, build, and fly remote-controlled aircraft. And so we have an annual competition where it switches between a military plane and a commercial plane. So what you can see here is our military plane of the year, which means we go to Tucson, Arizona for competition.
I'm Josh. I'm the team lead for Virginia Tech Motorsports Formula SAE. I'm a senior mechanical engineer. And this is our design team where we design, build, and then compete with 2 Formula One style vehicles. Not quite at the scale of Formula One or IndyCar, as you can see, but they're still open wheel, single seat race cars. And we compete annually against around 120 other universities through SAE international competitions. Our biggest and the first one that we go to is in Michigan at Michigan International Speedway. And the second competition that we go to was recently moved to Auto Club Speedway in Southern California. This is the electric vehicle right here that we're currently working on. And we also do a combustion vehicle as well. Both vehicle classes compete separately, but they're both under the same program of Virginia Tech Motorsports. So our team has a lot of electrical engineers, mechanical engineers, aerospace, and even some business folks as well. It's really interdisciplinary. A lot of good collaboration goes on here.
Hi, I'm Yanni Kusidis. I'm representing the Bolt team. I'm a junior in mechanical engineering, and I'm the co-team lead this year. The Bolt team is a design team under the mechanical engineering department. We design an electric motorcycle and race it. This is Bolt 4, our 4th generation motorcycle. This started off as a 2015 Yamaha R1M, a standard gasoline bike. We built our own battery packs and installed a motor and a motor controller, and now we race it as an electric motorcycle. It's made up of 996 18650 battery cells, similar to some you could find in a personal device.
This is the Steel Bridge team bay, and as we talked about earlier, Steel Bridge is a civil engineering project. Structural engineering is one of the divisions within civil engineering. I was a structural engineer for many years. I studied here at Virginia Tech in civil engineering, and it's a really great department, a great program. So what the Steel Bridge team does is they build a bridge that's up to 25 feet in span and can carry up to 2,500 pounds, which is about the weight of a Mini Cooper or a small Volkswagen Beetle. It's a modular design, so they build the bridge in pieces that are no longer than about 3 feet. And they have to assemble the bridge at competition. So they're judged on their construction speed, how many people are building the bridge, how much labor costs are involved. And then once the bridge is completed, they load it with angle iron, which start out at 25 pounds each, and over time eventually get up to 2,500 pounds. So it's a real structure that has to carry a significant load. The final project here in the Ware lab is the Hybrid Electric Vehicle Team, or HEVT. And as you might imagine, this is going to be populated mostly with mechanical engineering students, but we also have electrical students. We have computer science majors on this team. What this team does is they receive a brand new vehicle from General Motors. The vehicle is an all combustion engine type powertrain. They take the large engine that comes with the vehicle out, replace it with a smaller, more fuel efficient engine, and then supplement that powertrain with a 340 volt battery system. So this is an enclosed battery system here. This is the controller hardware, which basically communicates with the battery to tell the battery how much power it needs, depending on the driving condition, depending on the demands of the driver. Now, this team competes with probably 12 other schools in the United States. Unlike Formula and Baja, which have maybe over 100 participants, everyone on this team has to pre-qualify. Universities have to pre-qualify before they can be in the competition. Virginia Tech is probably easily the top 3 schools that compete in this project on a regular basis. They took first place in 2012. They've been consistently second and third place since I've been here at the lab over the last 12 years. So they are a very strong team that perform well every year consistently.
Welcome, class of 2025. You're in the Virginia Tech Helmet Lab, home of the Virginia Tech Helmet Ratings. We're a full-fledged injury biomechanics lab. However, we're best known for our football, hockey, soccer, flag football, and bike helmet ratings. And we continue to expand those ratings into various other sports. Here's the football helmet display. And over here we have the hockey helmet display. And I'm going to show you a few of the ways undergrad students get involved with all of our helmet testing. We're going to show you a couple of our impact testing devices. So let's cruise right over here. This is our head-to-head helmet setup. This is where we do soccer, flag football. And basically what we do is we impact these two heads. One of the heads has sensors and the other one has headgear. And we determine how well that headgear reduces some of those head accelerations to reduce injury risk. Here's our bike tower helmet testing area. This is another area where our undergrads help us test the multitude of bike helmets on the market currently to help with our Virginia Tech star ratings. Here's a display of some of the helmets we've tested in the past. Football primarily. We have some hockey, working on equestrian sports. We're also working in the snow sport area with the USA ski team. With the equestrian area, working with the United States Equestrian Federation, the United States Hunter Jumper Association, and the United States Eventing Association.
We're here at Smart Lab in ISE department, and this lab is under the supervision of Dr. James Kong. The SMART here represents smart manufacturing, analytics, research, and technology. Here we build smart machines, which means the machine have advanced different type of sensors, and it's going to collecting the data during the printing, collect all the processing parameters, and we're doing analytics for all those information together and trying to make the machine to do their own smart decision to make the part, make the product to have a better quality. And right here we have a very advanced laser printing platform. We use laser to melt thin layers of a powder onto a substrate and do it again and again. Then we can stack the geometries up and making 3D printed metal parts. And we use thermal cameras, 3D scanners, digital image correlations, and other sensing techniques to monitoring the whole process, and finally correlate everything together, make the part to have a nice quality. Yep.
So the space we're in right now is the build lab, and as you can see, there's so many tables, open spaces that students can come and just build whatever they want. We have 3D printers, laser scanners, saws, and kind of anything you can think of along machinery lines. You have to get certifications, and then once you have all the certifications, you can come here, get help from people that are older than you, and they'll just let you build whatever you want. I've seen people build wooden name tags, poker tables, any tables, and honestly anything that you can imagine.
Welcome everybody. Fantastic to see you today for the first class of NG 1215, Foundations of Engineering, one of the most important and I think really exciting first classes you're going to take at Virginia Tech in your fall 2021 semester. So great to see you all filling up the class. Sorry you can only see half of my face today. We're in the middle of a pandemic, but nothing stops us at Virginia Tech, and we're keeping going with teaching our first-year engineering students. So what's our program for today? Well, the first most important thing is I have to congratulate you on getting an offer to study engineering at Virginia Tech. What a great opportunity to come to one of the really top engineering schools in the country, even internationally renowned, and to join this program and in fact to be with these classmates. I'm so excited to be working with you as well. So I'm your instructor for today. I'm Dr. Jenny Case. I'm going to tell you a little bit about myself, and then we're going to go into a little taste of what our class is like. I'm going to take you through something about how the first day of class feels, and then we're going to fast forward to a class sort of towards the end of the course so you can see where we even get to over this course. And then I will be saying goodbye, hopefully to welcome you back in person in the fall. So let's get going. So here's the first thing you've been puzzling about, because you've been listening to my accent, and maybe some of you could place it, but many of you, I'm guessing, could not. So I am indeed South African. I've been 4 years at Virginia Tech, and that actually speaks to what I said already. This is an amazing university that draws international researchers from around the world to come and have their careers here. And I was drawn to come here to join Virginia Tech in the role of Department Head of Engineering Education. As you can see, I taught chemical engineering at the University of Cape Town for just over 20 years. And my research area is in engineering education. I focus my research on how do we improve teaching and curriculum to produce the kind of engineers that we need in the 21st century. So it was really exciting for me to come here. And that's right, it's not only wonderful to be at the university, but also just popped here a few things that make me passionate about living in Blacksburg. I love walking in the outdoors. I know for many of you that's been an attraction of why you chose us. My favorite place is Pandappa's Pond, just outside Blacksburg. I have the best cycle route in the world, so I get to cycle from my home through to campus. It's just gorgeous. There's my favorite coffee shop, Idigo Coffee. There are a couple of other good places around. I love the views from my office, from my deck. I think of a little picture here. Yeah, there's some live music at the Blacksburg Farmers Market, which many students go to every Saturday. In fact, last Saturday had huge queues, even though the weather was just above freezing point. So, wow. Let's get going, though, on our course. So, right, let's get going with our first class. I need you to take out a piece of paper. And I know you're sitting at home watching the video. I still want you to take out that piece of paper, get a pen, and you're going to draw for me what do you think engineering is. Do not worry about your artistic skills. Just quickly take a moment and draw something. Right. Now, you don't have to do what you would do if you're in my class, which is you're going to have to put that in the assignment place, because in fact this is your first assignment in the course. Not that we give it too much of a grade, but we get going with teaching you how to work our system. But I'm interested in what you were just drawing at home. So, did your drawing look like anything here? Did you draw a little electronic component, maybe something with gears? Did you maybe draw a blackboard full of equations, a car or an airplane? Did you think about the Earth? Those are just random pictures that suggest some of the drawings we often see from our first year students. I wonder if anyone out there drew a person in their image. I would be really interested if you did draw a person, because part of what we do in educating engineers at Virginia Tech is build people who can engage with society, with environment, with business, with all the things that engineers are required to do and be ingenious about. So, I want to just talk briefly a little bit about this course, because in fact that's a great start, is to think, what do you think is an engineer and why did you come here? So we recognize you definitely had some good reasons for choosing engineering, but often some of you even have engineers in your family or in your community. But you may have got to know like a mechanical engineer very well, and you started to think that's what engineering is all about. We want to broaden your idea of engineering during this class. So here is how we do it. So in this course, we look at what do different engineers do. For example, at Virginia Tech, we have a huge range of majors, and some you will never have heard of before. Biological systems engineering, for example, is the one that many of my students have never heard of before, and we look to find out what that is. What is industrial systems engineering as well? And others that are maybe not so familiar to you. As I mentioned, we're really interested in the holistic parts of engineering, and the ethical impacts of engineering, and the needs of society. We start teaching you how do engineers solve problems, how do engineers model systems, and then really importantly, number 5 and 6, sorry guys, if you thought you were coming to a career where you're just going to work on your own and solve problems. You're going to be in teams from day 1 at Virginia Tech through to the very last day of your career. And you're going to have to communicate your work every day. And we're going to make a big start on teaching you a lot about those 2 skills in this course. So just to talk a little bit more about what I really want you to learn in this course, what really matters for me. And this really picks up on a few things that I was already starting to hint at in the last slide. You came here because you're good at math and science, and well done, you got the offer to come to us based on the wonderful marks that you got in high school. But really importantly, engineering is not just about being good at the mathematics or the science. You have to think about impact on society. You need to back up your claims with data, and this is really important what we teach you throughout this course, but really emphasizing in the final module. You can't just give us an opinion, you have to be able to say where the evidence comes from. If you can't explain things, you're never going to get anywhere. And then really importantly, and this is a wonderful part about how this course plays into your first year, you have a whole year in which to choose your major. And you're going to, in our course, get to know what are all the different engineering majors, how do they work together. Some of you came in with a very firm idea of what you want to do. I want you to leave here with a stronger idea of why you made that choice. Some of you don't know that yet, what you want to do, and that's actually perfect. It's really a good thing to come into this course and use it to explore what you're wanting to head to in your major. Right, so just briefly, a little bit about the course. It has 3 modules. We start out very much looking through product exploration. We looked at how do different engineers work together. Module 2, I have to confess, is my favorite part because I like something I can really get my teeth into. And we work in it with a computer program called MATLAB. Some of you are computer whizzes. I know that, and I love it. You know more programming than I do. For some of you, you're totally new to this. And what I feel really good about every year is at the end of this course, all my students leave feeling confident about programming, because that is part of engineering life in some way or the other. And then in module 3, which we're going to jump to very soon, we actually go into ill-structured problem solving and what that means for engineering. So jumping into module 3, I want to give you a little flavor of a class that I ran in module 3, and I called this case study number 1, Build More Lanes. You might be wondering, what on earth does that refer to? Well, it does refer to traffic. And here's a piece of quite an interesting, slightly dated data that from TomTom that has collected data around traffic congestion. And it's very interesting to have a look and see which are the 10 worst cities for traffic congestion. So look, you're very fortunate to live in the US and that we're not right up at the top. But interestingly, if you add in Los Angeles, it fits somewhere, when this data was done, somewhere between Beijing and Brussels. But traffic congestion is a huge issue worldwide. More urbanization and just the answer, build more lanes, which is kind of how we thought through the 20th century, just build more roads, build more lanes, has not solved the problems. Because have a look here. Oh, I also wanted to tell you, this is not new. Here's a poster from 1960s London showing a bunch of cars. How many cars does it take to transport 69 people? What happens if we all put them on one bus? And you can see here's the issue. One thing you can do is build more lanes. The other thing is you change the modes in which people get transported. So I mentioned Los Angeles. Some of you might have been there. I've been there, and I can totally vouch for the traffic issues there. Here's the problem with build more lanes. Maybe you can't see the detail. These are a bunch of US cities, and it's telling you lane miles per square mile. In other words, how much road capacity does the city have? Los Angeles outstrips a bunch of other places, Detroit, Phoenix, Washington, D.C. It has lots of roads, and still it is one of America's most congested cities. So that sort of gets us a little bit into the topic. A city that really fascinates me is Beijing, because not that long ago, most of Beijing got around on bicycles. Look at the data from 1978. 5.6 million bicycles were in operation, and a really tiny amount of cars. And with the changes since the 80s, in China, the pattern is flipped around, and Beijing looks more like a world city with the kind of car problems. Interestingly, I was reading some information here. Oh, here's a picture of Beijing way back. You would see huge cycle lanes and so many people on bicycles. They're trying to reverse that, which is really interesting, and they're actually shared bike schemes now in Beijing. And then I just had to add something in from my home city in the world, this issue of building lanes, and this uncompleted bridge in Cape Town has become a very famous area for filming movies. You may see it at some point in a movie set. Cape Town is also a big place where movies are filmed. This is part of a freeway system that was built in the 70s in Cape Town. It did transform the city. It also cut the city off from the ocean. And then the money ran out. And this has been a debate for decades since then. Should we complete this part of the freeway? And actually the city has changed in its orientation to think this would not necessarily solve our problems, to carry on building more of these flyover bridges. I'm personally pleased about that, because in a way it's also it's created a wonderful character in the city. Oh, and this very funny thing. You can imagine the kind of movie things that happen off the end of that bridge. So my final little piece, just to open up this conversation, and as you can see, I'm quite passionate about public transportation. Oh, I want to give a big shout out for Blacksburg quickly. For a small town of this size, it is extraordinary, the public transport system that we have here, and which you as a student get to use. And so really I'm very proud of Blacksburg's management for pulling that together. This is obviously a little snapshot from the subway in New York. But I love this quote from a previous mayor of Bogota in Colombia, which is a city that's also had big issues around transportation. A developed country is not a place where the poor have cars. It's where the rich use public transportation. I think that's an extraordinary vision of clearly a way forward that we're going to have to embrace as humanity, and engineers have got a key role to play in that. So right, everyone, I hope I've opened up some puzzling thoughts to you about this problem of traffic congestion. And we've looked at a couple of different cities around the world to see that this is a really big problem for humanity, but engineers have got a key role to play. So now I'm going to quickly tell you about your team assignment that you're going to do. And remember, we've been doing a lot of these assignments throughout this course, and of course a lot of your grade in this course has come through the projects that you've been doing in a team. So in your team, what you're going to do is you have to pick a city. I'm giving you 10 minutes to get discussing on this in the class. So pick a city that someone knows a little bit about, or that you're just interested in, by the way, because it's very easy to find information. I want you to remember what we did about defining the problem, and stop and think, what is the real problem going on in the city? So unpack it in a bit more detail than just saying there's a traffic issue. I want you to use the internet to quickly scope out what solutions have been already attempted or not attempted in trying to solve this problem. And then finally, I also want some comment from your group on who are the stakeholders. Remember, we've defined that term in this class. Any engineering problem always has stakeholders. Who are they, and what sort of interests will they have on this problem? So, okay, you're going to go off and do this right now. Remember, when we come back, your group needs to have a reporter. That is a person who can report back to the class. And remember how I insist that you always choose someone who hasn't spoken a lot in the class. So do be ready to have your reporter to report back, introduce themselves, and so we continue to get to know who are the students in the class. Right, everyone. Well, thank you for joining me today. That was your little taster of NG 1215. We started out a little bit about the first day of class, and then we went right to the end to give you a feeling about what we're doing by the time we get to Module 3 in this class. I really hope we're going to see you here in fall 2021. I want to reassure you that whatever challenges we're still facing at that point in time, definitely engineering is going to be on the go here. The general engineering program is going to be ready to be teaching you in this course and in the other really important courses that you'll be doing during your general engineering program. Myself, together with the Hokie bird, really, really look forward to welcoming you here. And thank you for joining me today. Goodbye.